Okay, in this section we're looking to see if two functions are inverses of each other. And the big way we want to see if they are inverses of each other is if they're compositions, if we put one into the other, if they both equal x. So when we put them in, they both must equal x. So in the first one, they are the same. We have negative 3 over x for f and negative 3 over x for g. So for the first part, for f of g of x, I'm going to put the g function in where I see x in the f function. So that's going to become negative 3 over negative 3 over x. Now, when you're dividing by a fraction, remember, we are going to take the top and keep it the same, and then multiply by the reciprocal of the bottom. So that's going to become negative 3 times x over negative 3. Well, nice thing is these will cancel, and we were left with simply x. So that is good, because we want, if they're inverses only if these compositions are both equal to x. Now, that's f of g of x. We also have g of f of x, but in this case, since they're the same, if I were to plug this into this function, they're the same function, so I'll get the exact same thing. So this is x as well. So these are inverses because they both equal x. If either one are any other thing than x, then they are not inverses. So let's look at this second one. We have negative x plus 2 and x plus 2. So first it says f of g of x, which means I'm going to put g in for f. So when I do that, that's going to give me negative x plus 2, because I'm just going to replace the x with the second function, and then plus 2 again. Now when I distribute the negative x, because I have that negative in front, I get negative x minus 2 plus 2. Now this gives me negative x. So I can stop right now, because I need both compositions. I need them both to just equal x, and right away I have something that equals negative x. So these are not going to be inverses. When you plug one into the other, they both have to equal x to be inverses. Anything else you get, and it would not be an inverse.